Okay, so this is the second of our simple harmonic motion experiments where we're calculating the period of a simple pendulum. So the apparatus we have here is one of our mechanics frames. We have a pendulum bob. Here, this is a plastic pendulum bob mounted on a string which passes through this fixture here, and then we can tie it off here, and that allows us to pull the string through in order to effectively change the length of the pendulum. So the experiment consists of two parts. We're starting off with this lighter pendulum, this plastic pendulum, and calculating the period here for a certain number of swings. So we're going to let it oscillate for a certain number of swings. We're going to take the time it takes for that full set of swings to happen, and then to calculate the period, we just divide the total length of time for that to happen by the number of swings that we actually measured. Okay, so it suggests in the booklet that we actually do a time of, we actually time 50 swings. In practice, that's probably a little bit overkill, and sometimes the pendulum motion can go slightly unstable. So for the purposes here, I'm actually going to use 20 swings to make the measurement. Okay, so what we need to do is we need to effectively change the length of the pendulum for each set of data that we put in this table. So our first length is actually 0.5 metres or 50 centimetres. So the way I'm going to do this is I'm going to present a ruler up at 50 centimetres here. I'm going to make sure I'm measuring between the pivot point at the bottom of this fixture here and where the forces are acting on the pendulum bob, which, as you know from mechanics, is basically at the centre of mass. The pendulum bob, which is going to be right in the centre of this sphere here. So, to adjust the length of the string, I'm going to undo this clamping bolt here, and I'm going to let this string slide through until it reaches the required length. So, let's have a look here. So for this is a lot easier in a group with more people. But yeah, that looks pretty close. So I'm just going to clamp that there. Okay. And then start the motion. We can pull in one direction, release, and start the stopwatch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I get a value of 28.03 seconds. So, next I need to adjust the length of the string to 0.45 metres or 45 centimetres. So I'm going to just do the same thing here. I'm going to look at getting that length to 0.45. I'm going to pull the string through until that's right in line with the centre of the bob. I'm going to tie it off. Then I'm going to do my measurement. Of course, this is quite difficult to measure exactly, and any errors here will actually affect the measurement that we take. So if we're not dead on our length here, we'll get a slightly different period. So you might want to think about ways that you could improve that. If you had a group of people doing this experiment, how could you ensure that distance there is being measured accurately? Anyway, so now we've set the length to 0.45 metres. I'm going to set the motion off again, and then start it when it reaches a position at the far end there. So I'm going to start now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so I've got 27.25 there. Next one, change the length of the string to 0.4 metres. So just as before, pull that through, just loosen that a bit more. Just check it after I've tightened it. Yeah, spot on. Okay. And let's get the next 20 swings. So reset that, set it in motion, and then start it when it hits the far side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 25.34. Okay, next length is 0.35. See if you get any faster at this. Oops. Missed this one. Try again, 0.35. That's good. And same again, another 20 swings. Now remember from theory that you should never have a pendulum motion that's further than 10 degrees because what happens is the equations start to break down because of the small angle approximation we're using it. So I normally pull it just a few degrees to one side and then start the motion going. Okay, so I'm going to start it again now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 23.87. Next length is 0.3 meters. So let's just adjust that. That looks good. Okay. And another 20 swings. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 22.19. 0.25 meters next. Okay. And let's go now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, 20.19. And then the last one is 0.2 meters. So let's just do that on there. Good. So, last one. Let's start that in motion. 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 18.09 for the last one. So you might notice actually that it doesn't really matter how far I pull the pendulum and start the oscillation. The period is always the same because nothing in the equation depends on how far you pull it away from that central position. You shouldn't go above 10 degrees because that can start to cause the equation to break down. But it doesn't matter if I just move it a small amount like that or a slightly larger amount, because what happens is the bob just swings faster, but the period is always going to be the same. What we're going to do in the second part of the experiment is actually use a different pendulum bob, which is this one here, which is a brass pendulum. So basically this is much heavier than the plastic pendulum we have here, but do you think it will make a difference to the period of the pendulum motion? And the clue here is to actually have a look at the pendulum equation and see what terms are actually going to be important. So basically what we need to do next is replace this plastic one with the brass one. Okay. And now we can start to make our measurements for the second part of the experiment. Okay. So to start with, I'm going to set the pendulum length to 0.5 meters. So you have to be careful to think about where you're measuring to and from for the pendulum. So basically we have to determine where the pivot point is and where the forces are acting on the pendulum bob. So the pivot point in this case is going to be at this point here, at the exit of this hollow section here, which is where the string starts to pivot around. And the forces are going to act, as you've seen in mechanics, from the centre of mass of the pendulum bob, so it's going to be in the centre of the bob here. So first of all, I need to set this to 500 millimetres. So I'm a little bit high. So I'm going to loosen this and decrease it slightly. This is a much easier experiment to perform in a group where there's more than one, because it makes this adjustment so much easier. So I'm just going to lower that down a bit until that is at the centre of the bob. So I think about there. So let me just trap the string there. Okay. So then what I'm going to do is I'm going to just pull the pendulum to one side and release, and I'm going to time the time it takes to complete a certain number of oscillations. In this case, in the booklet, it recommends 50 oscillations, which is okay. We will get the most accurate measure that way. But as we get a shorter and shorter bob, it starts to become a little bit unstable. It can sometimes look like it's going to strike the frame. So perhaps 20 oscillations will be sufficient to give us the accuracy of the data we need. So what I'm going to do is I'm going to measure the number of time taken for 20 swings. Then I can divide that value by 20 to calculate what my actual period is going to be. So I've got this already moving in quite a nice motion, so I'm just going to start the stopwatch when it reaches the end of travel, and then I'm going to record the value in the table here when it reaches that set number of swings. So as soon as it reaches the end point here, I'm going to start the stopwatch. So go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so that's 28.72 seconds. So now what I need to do is I need to change the length of the string to 45 centimetres, 0.45 metres, or 450 millimetres. So I'm going to do the same as I did before. I'm going to loosen the string here. I'm going to pull it through until we're at 0.45, which looks about there. So once again, I'm going to tighten that down and just time 20 swings again at that position. Bear in mind as well, remember a swing is one full oscillation, so just like the mass on the spring system, it has to go back to the same point to be counted as a full swing. So in this case, it's the time it takes to go one way and then back again. Okay, so when it reaches that far point, I'm going to start the stopwatch again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so now that's 27.09 seconds. So once again, I can divide that number by 20, and that gives me the actual period for that measurement. So on to the next one, which is 0.4 metres. To shorten it again. So let's have a look. We are there. So it's the same as 40 centimetres. Just stop that from rocking. So tighten that there. And as before, I'm just going to time 20 swings. So let's get it up and running. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 25.5 seconds. Okay, and the next length is 0.35 metres, or 35 centimetres, or 350 millimetres. Okay, 20 swings again. Oops, push that right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 24.87. Okay, the next length I'm looking at is 0.3 metres. So let's go with that. Two, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's 21.97. Okay, next we're going to 0.25 metres. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20.28. And then the last one is 0.2 meters. Okay. Let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 18.16. Okay, so now I can take these swings, divide them by 20 swings to calculate the actual period for all of these in the system. And now we have the heaviest pendulum thing. What I can do is I can take the data, and I can by rearranging the equation, I can calculate the equation for L in terms of L. So then, by rearranging this equation, by plotting L against T, I can draw a straight line, so L against the square of T divided by 2 pi, and the gradient of that straight line should be equal to G. So basically, by completing this column here at the end of the second pendulum and comparing it to my actual period, I should be able to calculate G using the system here. Okay, so see if you can get on with that. All the sample data from the table here, it was available online. Okay.